October 23rd, 2020. So here we are back in the greenhouse. This is going to be part 3 for how to build your own greenhouse. We're going to discuss different ventilation techniques and concepts today. So my greenhouse uses what's called passive ventilation. In other words, we don't have intake fans or exhaust fans on our venting system in order to facilitate good airflow. Instead, in this greenhouse, we take advantage of convective airflows, where basically warm air rises and cool air settles. And because warm air rises, if you have a vent that's real high up like this one is, you're letting that air out. You're drawing cool air in from the bottom, from here. And then inside the greenhouse, we do have a couple of fans for stirring and circulating air, because the other thing that you want to do is always be mixing the air in the greenhouse so you maintain a relatively constant temperature. And that also helps facilitate good airflow over leaf surfaces, which is important for good transpiration and good photosynthesis. It also helps keep moisture off the sides of the greenhouse and wet, moldy spots from happening, and all sorts of little things like that. But what I really want to dig into today is the concept of passive cooling. Now, I guess I should just stop for a moment and go into a few other things. It really depends on the crop that you're growing in the greenhouse. That is very important for how much cooling you're going to need to do, how much ventilation you'll need to do, what sort of temperature ranges you're going to want to maintain. All those environmental factors are governed in a large part by the type of crops that you're growing in the greenhouse. Now, as you see here in the greenhouse, I have fig trees, I have lemon verbena, I have lemon trees, I have chaya, that's a Mexican tree that the leaves can be eaten off of. You have to steam it first though. I have peppers, I have ginger, that huge green plant over there behind the jacket is turmeric. I have rosemary. So I have quite a wide range of crops, but many of them are tropically oriented, or they can handle tropical conditions. So, main things to consider for this particular discussion regarding venting, I'm talking about a greenhouse like this one, where the whole greenhouse is closed in. There are many different types of greenhouses. There's high tunnels, there's low tunnels. Some of them have roll-up sides, where you can roll the side up and let air flow through. Those are great for commercial application, but you know, there are some drawbacks, like you have to go out and roll those sides up when you need them up. There are some advantages to those. They do keep rain and moldy conditions off plants, like if you're trying to ripen tomatoes in a late fall season, you're getting dewy nights. It'll help keep the dew off, it'll help keep the rain off. But for this conversation and this context, we're just talking about a greenhouse like mine here that's entirely enclosed, and then you're trying to manage that environment. So again, this is specifically talking about airflow for this section. So what I'll do here is, a couple of nights ago I filmed some airflow characteristic shots of these vents. I took a cigarette and I showed the airflow coming in the vents and the airflow going out of the vents. October 20th, 2020. This is part of the greenhouse series, ventilation, airflow. Okay, so I mentioned ventilation and airflow. I've shut off all the fans in the greenhouse, and I'm going to do a smoke trail so you can see airflow. So first, with the vents closed, let's just have a look at our airflow characteristics here. You can see, I'll even tilt the camera up a little bit so you have a better dark background. You can see it flows up, obviously because it's hot smoke, but it really doesn't go anywhere once it flows up. Okay, that's by the out vent. And we'll go over here by the in vent and we'll take a look from here. I'll especially go down low where the cool air comes in normally, and you can see there's some air disturbance here from convective currents in the greenhouse, but for the most part it's not really moving very fast. Now we'll open those vents. And you'll see that airflow characteristic change dramatically. See the wisps as it's curling? That's cool air coming in on the inlet vent, and I can tell you, I can confirm that's cool air coming in. And now you can see the warm air literally float right up out of here immediately. And so you can kind of get a gauge, a visual gauge of how fast this entire airspace over this vent is flowing. Pretty uniform, tremendous airflow. And so that's what you're aiming to accomplish. And when you want to ventilate a greenhouse, you want to be able to exchange that air very rapidly. And you can do that, like I'm doing here, convectively, by taking advantage of the difference in height between the inlet and the outlet. This is very, very, very much like water, and looking at water is vertical head, except in this case our water is air as our fluid, and our vertical head is the distance between the inlet vent and the outlet vent. And so in this case we have about a 6-foot difference between the two. So that gives us 6 foot of pressure effectively to move air. And so we're able to exchange air pretty freely that way. Now in the spring and fall, when the sun is coming in here hard and it gets very hot in here very quickly, we can do that, but we're still not really exchanging all the heat out of the greenhouse, and we're not keeping air temperature uniformity. And so that's why we run the air circulator fans. Right now it's just this little Vornado fan. I run it on a fairly low level. It doesn't take much to stir the air in here. When I get the solar system upgraded a little bit more, I actually have DC fans in here. These are 200 cubic foot a minute DC 12 volt fans. They're actually wired into that relay board on the controller, and there's 2 of them, and with those I can exchange all the heat that I need across, and I can either, when I'm trying to vent, promote that heat over to the vent quickly and send it away, or if the vents are closed, I can stir the air in the greenhouse and keep uniform temperature and humidity, and basically extract humidity off the walls and all those sorts of things when the weather gets colder. So I just wanted to kind of go into some extra detail about venting and ventilation, because those are some really important pieces of that. And I want to do a demonstration on airflow, so now you might have a better understanding about how that works. So that's this part. A visual concept of how that works. Now today I want to go over multisizing related stuff. So if you're going to do active airflow ventilation where you're using fans, you basically want to be able to exchange the cubic footage of air in the greenhouse once every minute. And that might sound really high, but I got to tell you, when the sun comes out and all that solar energy is coming in and there's no way for it to escape, it gets really warm in a greenhouse really fast. And so that's why that standard is the 1 minute exchange rate. I'll just mention on the side here that if you're growing in an indoor controlled environment, that same rule applies. The maximum lowest exchange rate would be able to exchange the full cubic footage of that space in 5 minutes if you're an indoor grow environment. But again, it comes back to the plants you're growing, the conditions you have, what your incoming air temperature is. That's a huge factor, because obviously if you have 90 degrees out and you're pulling 90-degree air in, then it's going to be a lot harder to keep that greenhouse at 90. In fact, you won't be able to keep it at 90 with the sun out. It's going to be more like 110. So count on expecting to see 20 degrees Fahrenheit over what the outside air temperature is. Even when you have good airflow, I would expect that. So that said, we're going to talk a little bit about passive ventilation. This greenhouse, I'll just say it again, is 288 square feet. It's 12 by 24, and it's 288 square foot of floor space. And so ideally for passive cooling, you want about 20% of your floor space for your ventilation vents, and that's for each vent, one for inlet, one for outlet. In this case, my vents are 54 square feet. No, I calculated that the vents should be 54 square feet. I didn't have materials to do that, and I didn't want to basically make half the greenhouse have to open up. So I went a little bit smaller on those. I think these are like, I think these are 3 foot by 7 foot, so that's about 21 square feet. That works pretty well. Works fine for, I would say, 75% of the year. During the summer, I don't really grow much in here. It's just too hard to keep up with watering and humidity, and it gets awfully hot in here. Although I find that things like ginger and turmeric seem to be able to stay in here okay as long as I can keep them watered. I may continue to keep ginger and turmeric in here over the summers. I did not this year, but I may add that to my program. Anyway, so it's really important that you're able to exchange that airflow, and part of that is, you need a way to open and close vents. Now they do make, they're basically a bimetallic strip mechanical version of a vent for opening and closing greenhouses, but they're fairly expensive, and they're usually not very big unless you want to spend a lot of money. So I don't remember what I paid for these linear actuators, but I think they were somewhere in the neighborhood of 30 or 35 bucks for each. They're these particular ones I think are rated at what are they rated at? 900 newtons, which is basically about 200 pounds of lifting force. And they don't really draw that much power, so I really felt that this was a great easy way to do this, and it's worked out really well. Of course, when you're building your own equipment, you have to be able to back that up with reliable controls for it. Let's take a look at that venting script. So this venting script basically takes readings from 2 temperature sensors. The inside sensor here, it's just looking at average greenhouse temperature, and the outside sensor, which is outside. And it reads those air temperatures, compares them, and then makes a decision based on whether outside and inside temperatures work with each other. So I think what I'll do to make this easier is I'll make another section of this video. We'll take a closer look at the code inside, where I can really drill into it with you and show you. But basically what we're doing is looking at outside temperature and inside temperature. If the outside temperature is above 40 degrees, and the average greenhouse temperature is above 85, then we'll open just the top vent that lets out heat from the top without letting air that's too cold into the inlet vent. And then if it's above 55 outside and 90 degrees inside, that's when we'll open both vents. So that's just the basics for how it works, and we check that every 5 minutes. And the other thing that we do here, I have these DC equalizer fans. Now ordinarily I have AC 110 volt fans in here. I'll just show you those quick. There's one here, that's running pretty much most of the time for circulation, for air. I have this other one here. This is I think it's 200 CFM. That's on an automatic fan speed controller, so I can run that at low until it reaches a certain set temperature, and then it'll rev up and ramp up. So if it gets warm in here, it'll start spinning air around more. I usually leave that unplugged. I don't find I need that very often anymore. But in addition to that, I have 2 other fans here. These are DC 200 cubic foot a minute fans. They're basically computer fans, but they're very high volume, so they move a lot of air. And so I use those for a couple different things. I use them to stir the air in the greenhouse after I've closed the vents. We stir any cool air and warm air back together. We mix that uniformly so that we have a nice uniform temperature. The other thing that does is that ensures that this inside sensor is taking accurate readings and not getting, say the cold air on the bottom, or just the settled warm air on the top and the cold air sitting below, making plants uncomfortable. So there's a lot to consider here, but you're basically always trying to maintain good circulation and airflow. And if you can do that, then you have a better gauge on where things are at. Okay, so now what I've done is I've manually closed the vents using the command line on the computer just to send the command to close these so you can get an idea how this works. So we're currently, actually I don't even know what the temperature is here. I don't have the chart up in front of me, but I'll pull a snapshot up of the chart and show you, and you'll be able to see where the vents were functioning and all. But it's obviously it's warm enough in here for those vents to be open and to be staying open because we have good sunlight out, and it's about a 72 degree day out I think at the moment. So I just want to show this script in action just so you can get an idea. So I'll run the script. This script is a loop, and this runs constantly, and it checks the temperature of the inside and outside vent temperatures every 5 minutes. When the vents come down, it triggers these circulation fans on for anywhere between 30 seconds and 2 minutes, depending on where I'm at in the grow season. Sometimes I'll extend it, sometimes I'll shorten it. But they basically mix the warm and cool air, taking advantage of the air that's risen up high and warm. Basically, we're circulating the cool air up into the fan, blowing the warm air across. It's feeding the next fan, which is blowing the warm air across, and that way we're maintaining uniform temperatures. And that really helps out a lot in the wintertime. When this end of the greenhouse where the stove gets cooler, those fans also come on, and they'll equalize those temperatures. I usually have sensors both on the west and the east end of the greenhouse, and I'll compare those, and if they get greater than 5 degrees in difference, those fans will come on for like anywhere between 15 and 30 seconds. Those sensors are down at the moment, so I don't have that hooked up, but I just want to illustrate the concept for you. I grabbed the wrong script before when I went to run the usual venting script. I should also mention that in the cron tab, I have a special command in the cron tab that makes sure that this vent script loads when this computer boots up. So even if it reboots, we don't lose that script from running in the background. That's always running to ensure that we don't cook things in here. I think one of the things that's most important for greenhouse controls and temperature, before you ever even think about putting heat sources in, you want to think about cooling and ventilation. Those are more important than heating. I just can't stress that enough. They're super important. Consider your ventilation application before you consider your heating. And then we'll get into heating. That's a whole nother topic. But I'll just show you real quick. We'll run the script. And you can see well, first of all, you can see that we're below 90 degrees in here because it's opening the upper vent and not the lower vent. So that's a good example of that. That lets all that heat out without drawing super cold air in. Now I suspect there's a script issue there because I had to rewrite the script for the new sensors, and I haven't double checked that to confirm that it's all completely functional. But I just want to illustrate how that works, how the system works, and just let you see that, you know, it's comparing those temperatures constantly, and then it'll recheck. See, it's waiting 1 minute, and it'll recheck and recalculate average temperature. Right now I'm just pulling from one sensor, but usually I'm taking sensors in the east and the west and the middle of the greenhouse, high and low, and actually comparing, you know, averaging and comparing to make sure that our temperatures are on point. I'll probably change that script over time as things evolve, but I just wanted to share that and show that. So one other point I want to reiterate here is ordinarily for a greenhouse, there we go, we hit over 90 degrees inside, and so that tripped open the second vent. Now we're letting cool air in. And boy, does that feel better, because I'm nearly sweating in here. I'm not even used to warm temperatures anymore. Anyway, so ordinarily you would want to preheat your air coming in. And I've sort of mitigated that by using, you know, the upper vent opening to let hot air out and not necessarily letting cold air in until the air is warm enough that it won't shock the plants too badly. Ideally, still, I would like an intake room that would preheat the air. I'm just not set up to do that right now. Don't have the time to implement that. And this has worked pretty well for what we're doing. But I will show you a clip. I did stop and get a clip of that commercial greenhouse down the road from me, and I'll just show you a clip of that right here. So this is that greenhouse down the road that I promised I'd get a clip of. You can see the building on the right hand side. That's part of the air intake, and there's actually, you probably can't see it now, but there's actually a divider between where those fans go in right there and where it goes into the main part of the greenhouse. That's basically the air preheat section for this commercial sized greenhouse. Just thought I would get a clip of that and share it so you could better understand it. Again, that's to control air temperature on the inlet. When it's cold out, you don't want to pull 30-degree air over your plants. And so now that you've seen how they do that commercially, I think you'll have a better understanding of how that works. So key takeaway points: good ventilation and control, good air circulation, and good management of temperatures. Be prepared to ventilate, ventilate, ventilate. You almost can't have enough ventilation capability or options in a greenhouse. It's amazing how much heat it collects, how much humidity can build up, and you really need to be prepared to vent that well. I would say it's equally as important, if not more important, than any heating system you would put in a greenhouse. I hope you found this interesting or informative. If you have any questions or comments, don't be afraid to do so down below. Thanks for watching the Pharmacy Seeds Network, and I think in part 4 we will probably go into heating, but we'll see how it pans out. Anyway, thanks for watching the Pharmacy Seeds Network.